All right, part 2, the scientific revolution. Okay, what was the scientific revolution? Most revolutions we think of as political revolutions, but this was not a political revolution. This was a revolution in thought, not in political control. So it was a movement. So it was not a specific start and end date, but people gradually caught on to these growing ideas and were encouraged by each other's scientific discoveries and inquiries, and it was this trend, or this movement, scientific thought and inquiry. And it was initiated in the mid-1500s and then kind of ended, you could say, in the 1700s in Europe. But really what results from this is that it just kind of dies down and is stagnant with all these new scientific discoveries until the Industrial Revolution, which is where we pick up with World History 2. So this was started in Europe. But they did borrow from other cultures, but a lot of the ideas were made by Europeans themselves. And a lot of that was due to the secularism and the humanism ideas that were directly linked to the scientific revolution. So as more people were intrigued about humans and the human body, what we're made of, what's really in the heavens and the sky, as our faith starts to weaken in the church, then all these things kind of come together to produce a secular study of science. So it questioned the nature of the world, society, and knowledge. So how do we know what we think we know? So there were all these advancements, most notably in astronomy, chemistry, physics, and biology. Advancements in instruments, such as the telescope, allowed us to have advancements in astronomy, things like the microscope in biology, and just different scientific experiments. Astronomy was very important at this time because people were very interested in the heavens, and they were also interested in going places. And it turns out the skies are very useful at having us go places, telling time, telling our position in the world, by the stars, etc. So a lot of these beliefs totally uprooted these widely held beliefs about the world. So these people were finding out new information every day that was basically turning society's knowledge on its head. And because society's knowledge was based on the Roman Catholic Church, many of the advancements of the scientific revolution contrasted many of the beliefs taught by the Roman Catholic Church. So these scientists were not friends of the church for the most part. Our first scientist is Nicholas Copernicus, and his name you might have seen before because it was in that DBQ we did on humanism last week. So historically, Europeans believed in geocentrism, so geology or geography, study of the earth. Geocentrism, the earth is in the center of the universe or solar system. So this was the incorrect belief that the sun actually rotates around the earth, because we knew it rotated. But Copernicus proved and built upon previous theories that the sun was actually the center of the solar system, and the earth revolved around the sun. This is called heliocentrism. And next year when you take chemistry, you'll know that helium is one of the gases that makes up the sun, and they have the same root word, and I believe it's the Greek root word for the sun. So that helio, that's sun. So he observed this exclusively by himself. This was kind of a popular idea of one of his teachers, and so he kind of expanded upon that and built upon that. And he discovered that the daily rotation of the earth on its axis and the revolution of the earth around the sun. So not only that once a day we have one full rotation around our own axis, but once a year we make one full rotation around the sun. Now, in the Bible, because the people who wrote the Bible also believed in geocentrism, they believed that the earth was the center of the universe. However, Copernicus went against this idea, and he was then put on trial and persecuted for going against the Bible and Christian beliefs with this radical theory. Now, this man's name, the J, is like a Y, so it's Johannes Kepler. He was a mathematician and an astronomer, and he was best known for his laws of planetary motion. He not only confirmed Copernicus's heliocentric theory, but he also proved that planetary orbits are elliptical, so they're not perfect circles, they kind of wobble in an egg shape. And he identified and named 6 known planets. And as you may know, the planets are named for Roman gods. So things like Venus, Mercury, Mars, Jupiter, Saturn, Neptune. I think those 6. Those 6 are the ones that he discovered. And they are all named after Roman gods, which is important because when we talked about humanism and secularism, in the Renaissance, they wanted to throw it back to the good times, to the height of the Roman Empire. So that's maybe one reason why Kepler picked Roman gods and goddesses to name our planets, because that was his historical context. Everything wanted to be about Rome. And his scientific work served as the basis for Newton's discovery of gravity, which he is our last scientist of the day. So then we have Galileo Galilei, who we've also talked about. He's a physicist, mathematician, engineer, and he's credited as the father of astronomy because he helped perfect the first telescope and, in turn, provided definitive proof for heliocentrism. So again, all these scientists are kind of building off each other's works and kind of supporting each other and inspiring each other. So that's why it's a whole movement. So he also studied sound and its transmission and offered significant contributions to the mathematical understanding of time, which also helps people travel. And he discovered that falling objects accelerate at a fixed and predictable rate. So he dropped a ball and a feather off the Leaning Tower of Pisa, and they hit the ground at the same time. So he knew that weight did not matter in how fast things accelerate from a vertical location. Now, Francis Bacon, you may have heard of also, and he is credited as the inventor of the scientific method. So every time when you go into science class and you have a question and you make your hypothesis and then you do your experiment and you have your independent variable and your dependent variables, your 3 trials, and then you draw your conclusions, this is Francis Bacon's method. And he believed that science is established through a systemized investigation, repeated trials. So it's when you repeat an experiment and receive consistent results that you can then draw conclusions that can be generalized to scientific principles. And this really is the basis for every science experiment that is still even being done today. So this was very important. This was how to do science. So people would kind of play around and maybe have theories about things, but then not have a established, systemized way of repeating those trials, or maybe not think that that systemized way was necessary. But as we know, just because something happens once doesn't mean it is going to happen every single time. Now, Isaac Newton, very important guy here. He discovered the force of gravity, which you may or may not know, that is minus 9.8 mass squared. Every object is attracted to every other object. So every object has gravity. The Earth's gravity is negative 9.8 times the square of the mass. And so different planets have different gravities. But he discovered Earth's gravity. And he also created these laws of motion and universal gravitation. So number 1, Isaac's first law, Newton's first law, an object at rest will stay at rest. Objects in motion will stay in motion. He discovered force equals mass times acceleration. And for every action, there is an this should say opposite, not object. So there is an opposite and equal reaction. So if you push back, if you push, there will be a push back. If you go up, you must come down. And he applied these laws of motion to planetary orbits, comets, tides, equinoxes, which is Saturday, March 21st. And it further proved the heliocentric theory. So Earth must rotate around the sun because the sun has more mass. So we are attracted to the sun's gravitational pull. So again, building on everybody else. So next class we are going to work on how these scientific discoveries really shifted thought in society and really kind of turned everybody on its head and what it did to the rest of their belief systems.